the class. Okay, so what we are going to do today, we are going to move on to section 3 in chapter 8. So in chapter 8, section 1, we learned how to simplify a radical expression. In section 2, we learned how to add or subtract the radical expression. Now we are going to move on to the multiplication and division of radical expressions. So before we start here, let me just give you, this is not hard at all. If, okay, I said if we know how to simplify a radical expression. So to basically, the rule tells us if we have two radical expressions, radical capital A, so this A can be anything, as long as A is a non-negative number or expression, that's okay. So we have one radical expression, radical A, and if it multiplies another radical expression, B, and then the rule tells us we can just multiply the two radicals and make them stay in the radical symbol. So radical what? A times B. See what we have done? We have combined those two radical expressions into one. And after we have this one radical expression, we'll go back to section 1. How can we simplify this radical expression? In one word, we want to move the factors out as much as possible. Whenever one factor has an exponent greater than 1, then either the part of 8 or all of 8 can be moved out, depending on the exponent is an even number or odd number. So that is the only thing new we learned today. The operation on multiplication is this rule. Multiply two radical expressions. We just need to multiply two radicals and then simplify this radical expression as we did in section 8.1. Quick example. Okay, so if I have radical 2 times radical 3. Okay, and what is result? That's radical 2 times 3, and then the 2 and 3, you'll see each one of them has a power of 1 only, so nothing can be moved out. Then just multiply them out, radical 6. Okay, so now if I give you another one, radical 2 times radical 6. Still, step 1. Put the two radicals together, 2 times 6. And then when we look at this one here, my recommendation, you do not multiply those two numbers out. So you do not. So you could do this, but I do not recommend you write this one down. So instead of multiplying those two radicals, we factor each factor if possible. So 2 is a factor and 6 is a factor. We'll try to factor both of them. 2 is still 2. What is 6? 6 equals 2 times 3. So now, after we finish the factorization, we notice there are two 2's within the radical. So 2 times 2 means what? 2 times 2 means 2 squared. And we know 2 squared can be moved out of the symbol. So in that, whenever you see two same factors within the radicals, they are multiplying, and you can move each group. So 2 times 2, you can move them out, and we'll have 1, 2 out. So 2 2's, we move the 2 out, we'll have just 1, 2 outside. And so those 2 are moved out. What is left? We still have 3 within the radical symbol. So the right answer should be 2 radical 3 instead of leaving radical 12 there. So if you want, okay, something, so professor, my habit is, I know the rule, just multiply the two radicals. So can I still, so go to the radical, I know 2 times 6, that's 12. I get 12 here. Nothing wrong. If you get here, that's okay. But just remember, for all radical expression, we have to make sure it is simplified. So which means that is correct, but you cannot stop here. Then what do? You have to use the factor tree. How do I simplify radical 12? So use the factor tree right here. So 12 equals 2 times 6. 2 is prime, 6 equals 2 times 3, prime, prime. So you're going to continue to factor 12 as 2 squared times 3. And then equals what? Equals 2 moved out to radical 3. That's okay as well. But compare those two ways. Why I do not recommend this. See, you multiply 2 and 6, and then later you still have to break 12 down. So instead of doing this, so I can directly go from here to here. And we really don't have to get 12 here. Okay, so this is my recommendation. When we multiply two radical expressions, when we multiply the two radicands, and no rush to multiply them out. Instead, we try to factor them out. Okay, so now let me see if I have more examples. So here we have three radical expressions, and we want to multiply them out. What do? Same thing, just draw a long radical symbol here and multiply all radicands. 11 times x times 33 times y times 3xy. Okay, so we have three monomials. They are multiplying each other, like what I did. Okay, so I have, so first we multiply all numbers. 11 times 33. So for 33, we know we can write it as 3 times 11. So that is my 33. I skipped one step. I directly factor 33 as 3 times 11. There is another coefficient 3 here, times 3. So this 11 times 33 times 3. And then we just multiply the variables. I have x, I have another x. So those x times x, that means x squared. And I have y here, I have y here as well. So y times y is y squared. So multiply or put all radicands together and then factor each factor if it is possible. Now, let's see, what can we move out? I see 11 here. I see another 11 here. So 11 can be moved out. So 11. I see 3 here. I see another 3. So times 3, those two 3s can also be moved out. We'll turn just 1. And we have x squared, so any variable, when it has one even exponent, they can all be moved out. And x will be moved out. This new exponent will be half of the exponent inside. So squared, then moving it out, I have just 1x here. And y squared, take the radical, we'll get y here. And finally, write this down, 11 times 3, 33xy. Okay, so that is the simplest multiplication. So when we multiply the radical expressions, and we'll just multiply the radicands. So sometimes, okay, so when we have two radical expressions, we might have this. For example, I have radical 2. So this is one radical expression. Okay, it's one term radical expression, pretty similar as the monomial and polynomials. So this is one term radical expression multiplied by what? Multiplied by another radical expression. But the other radical expression has two terms. It's something like a binomial. So how do we multiply this radical expression by another more complicated radical expression? Nothing new. What we have to do, just remember, just treat the radical expression or multiple term radical expression as a polynomial. So think about how do we multiply a monomial by a polynomial? We use distributive law. And same thing here. So this monomial times the first term and then times the second term using the distributive law. So it turns into what? It turns into radical 2 times radical 2 and then plus radical 2 times 3. Distributive law. Then what do we have here? We'll have the simplest multiplication, a single term radical expression times another single term radical expression. What do we do? Multiply the two radicals. So 2 times 2, 2 squared. Radical 2 squared, that's 2. And then plus, when we multiply a number by a radical expression, we always write the number in front of the radical expression. So we do not write the radical 2, 3. We write 3 radical 2. Very similar to like x times 3. And we do not write this x3. So we don't do this. Okay, we always write this as 3x. Same thing here. So from now on, what we are working on, what we are doing with the radical expression, that is exactly similar to working on polynomials. Okay, so if I'm talking about polynomials, now let's look at another special radical expression. Radical 2 plus 3 times radical 2 minus 3. All right, so what do? We'll treat this. So this still multiplication, polynomial times polynomial. And those two polynomials, they happen to have two terms. That is binomial. And recall what we did on binomial. So binomial times binomial, we use FOIL rule, F-O-I-L. So apply FOIL rule on the multiplication of two-term radical expressions. So that will be, okay, what do we have? We have first times first, radical 2 times radical 2. Oh, outer times outer. So that's plus radical 2 times what? Negative 3. So this is negative 3. And then inner times inner, plus 3 times radical 2. And outer, no, L, last time last, plus 3 times negative 3. So we have 4 multiplication now. Work on each one. Radical 2 times radical 2, that means radical 2 squared. That is radicand, that's 2. And then we have negative, positive, turns into negative 3 radical 2. And 3 times radical 2 is still 3 times radical 2. 3 times negative 3, that's negative 9. And what do we do next? Combine like terms. What are like terms? Combine like radical expressions. So those two radical expressions happen to have the same radicands, they are like. If they're like, we can combine them by combining the coefficient. Negative 3, 3, they cancel those two terms. They actually cancel each other. What is left? 2 minus 9, that is negative 7. So this is the regular way where we have two-term radical expression times another two-term radical expression. General way, using the FOIL rule. But, okay, I want you to notice those two radical expressions, they are very special. What's special? They have the same first term. They have the same last term if we just ignore the symbol. So the first one is the sum of the two terms. The second one is the difference of the two terms. Recall, what we did in chapter 5. If we are multiplying two binomials, sum of the two terms times difference of the two terms. Okay, a plus b times a minus b equals what? Equals a squared minus b squared. This is called difference of squares. And this semester, remember in chapter 6, we did the opposite way. If we are given the difference of 2 squared, we can factor it. So recall, this is a very, very important formula. Okay, so sum of two terms times difference of the two terms equals square of the first term times square of the second term. This applies to polynomials, general polynomials. It can be applied to the radical expressions as well. So we go back to this multiplication. I want you to notice. So this is the sum of the two terms. The second one is the difference of the two terms. So instead of using the FOIL rule, I can directly apply that formula here. Sum times difference equals what? So this is another way. Equals what? Equals square of the first term. The first term is radical 2. Square 8. Always minus square of the second term. That's 3 here. Minus 3 squared. And see, what does this equal to? Remember, square and a radical symbol, they are opposite operations. So those two can cancel each other. Square of a radicand, that will be the square of a radical expression is equal to the radicand. So square of radical 2, that is exactly 2. And then minus 3 squared, 9, that's negative 7. See, compare those two methods. Which one is easier? Applying this formula directly is much easier than the 4. You have to carry the 4 multiplication. Then you have to combine. All right? See, that is very, very special. And I want you memorize. This is super, super, super important. Recognize those two radical expressions. So what radical expression? Within the expression, we have the radical symbol. That is radical expression. There might be one term, there might be two terms. So if we have two term radical expressions, and those two seem like a binomial, all right? If those two radical expressions happen to be only difference at the symbol between the two terms, one is addition, one is subtraction here. Those two binomials or those two radical expressions, they actually have a very special relationship, and they are called the conjugate to each other. So here we have one terminology. We will be using it pretty soon in the division later. So the first radical expression, so two-term radical expression, is the conjugate of the second one. The second one, when we have subtraction here, is the conjugate of the first one. So those two, they are conjugates to each other. Something like they are brothers, they are sisters. So that's a family, conjugate family. And so what kind of radical expressions they are conjugate? So they will have everything identical except one is addition, one is subtraction here. Okay, so having this in our mind here, I'm just asking you, if I give you this, okay, so here comes the problem. If I have radical x plus radical y, and can you tell me what's the conjugate of this radical expression. Okay, so we say, oh, there are two terms, and we have the addition here. So A's conjugate, we cannot write equal. They are not equivalent. We just replace the addition by subtraction here. Radical x minus radical y, that's the conjugate of radical x plus radical y. So to find the of course, if we are given this one, the conjugate of the second one will be this one. So those two are conjugate to each other. When we are multiplying two conjugates, so those two radical radical expressions are conjugate to each other, we can simply just apply this difference of square formula. So conjugate, okay, so that will be like this. So radical A plus radical B times radical A minus radical B equals what? Equals A minus B. How did I get A? Because radical A squared, that is A. Radical B squared, that is B. So squared minus squared, that is A minus B. So remember this one here. See what we have. This is the preparation for what we are going to do next. When we multiply a radical expression by its conjugate, so when we have one radical expression and we multiply it by its conjugate, we find out what happened. The radical symbol disappears. See? So if we have one radical expression, we have some radical symbol inside of the expression. To get rid of the radical symbol, what can we do? We just look for its conjugate and then multiply its conjugate. Then, because the square can get rid of the radical symbol, we have squared minus squared. Then the radical symbol is gone. And so this is a very, very special multiplication, a two-term radical expressions. There are two special radical expressions. They are conjugate to each other. We need to be able to look for the conjugate of one radical expression and then be able to multiply this radical expression by its conjugate. If we know how to do that, and then the division that we are going to do next will be a piece of cake. Very, very simple. So this is the second type of multiplication. So we have learned how to do the multiplication on the single term radical expression. Then we learned how to work on the multiplication of multiple term radical expression. Can be and just treat it as the polynomial. All right, so I think that's all I need to share on the multiplication part. Let me stop recording.